Before we get into this video, I just wanted to mention something that came up in the previous video. The video quality wasn't great. I went back and watched it and it seemed okay on my side. Apparently what's happened is when I shoot the videos, they're shot in high definition, but for some reason when I'm uploading, it could be my camera because I'm shooting with a new camera, so I'm still playing around with settings at the moment, trying to get used to it. But it could be that the settings aren't set right on my side and they are uploading to YouTube on low definition. So just go to the bottom of your screen. If you find the video quality isn't great, just adjust that. They seem to be loading at 144 or 240, something like that. So just adjust that for the video anyway if you're finding that as you're watching the video. So getting into the reason why I brought you here, I was going to run this job through as a project video, I suppose, because I don't really do a lot of projects. The only thing I can show you is parts. It's not as interesting as probably projects, but they're the only things I can really show you. If you're interested in project videos, I do have a heap of videos on my channel, further back right at the start of my channel, where I'm rebuilding a Mazak CNC lathe. I know CNC lathes aren't for everybody, but there is a fair bit of work going on in there of rebuilding the whole machine. So I got a bit carried away and finished up rebuilding the whole machine. It finished up being a big mistake, but decisions that you make at the time don't always work later. So I won't go over that. I talk a little bit about that in some of the videos. If you're interested about projects, definitely go back and watch those videos. But getting back to why I brought you here, I was going to run this part through as a project and just walk you through making the whole part from bar stock. I showed you in the last video where I was rounding the ends off on the manual lathe, and I was saving a couple of parts where I was going to run the whole job through and just show you the whole procedure. As interesting as that could be, that's the closest I can get to as far as projects go. So I've run those through, I had to push those through. As you can see, they're done there. So I run the whole 250 through. Normally I would run these on a manual lathe, but thankfully I've got a CNC lathe now, so CNC lathes aren't as bad as what some people might assume. They are a little bit sleepy machine to run, but the good thing about it is volume work. You can't go past them. But previously I was running 60 of these at a time. So I've already taken 60 out of what's here now, and they've been sent off to heat treatment, and I'll just keep these in stock as the customer requires them, and I prepare them 60 at a time and just go through them. So there is some work on these, as I say, not a big deal part, but I have to bend the part and weld a bush onto this part. So I will include a card at the end of this video that shows you MIG welding the bush onto this actual part, where I'm welding just doing it freehand without a positioner. Not everyone can afford a positioner or justify a positioner. Even though I have one, I don't use it that much, to be honest. It was probably a waste of money buying it, but it's there for when I need it. For those who are interested, I do have a couple of videos on my channel as well of that positioner, the VVOR positioner, some people like to call it. But there is some videos on there of that as well. So if those guys are interested about welding positioners, and as I say, there's a couple of ones doing a manual setup too. So why I keep getting away from my story, but I had to get another part done. So I pushed these through because I had this job come in, a customer job come in. So I had 400 of these to do. Nothing big deal, 1045 steel, with 16.5 mil hole through the center, 32 mil bar, approximately about 110 mil long with a couple of threads at each end. So I had to get these done. Got those pushed through. No time to do a video because these were important to get done. These have been finished. This is just a sample part, and these are already going to a customer. So I do plan to take you over onto the CNC lathe, as exciting as that might be. You're already thinking CNC, you're already starting to fall asleep for you manual guys, but I try and include as much information as I can to try not to drag it on as too long and just show you an actual part that I'm running over there at the moment. So I'll just take you over there and we'll have a look. As I mentioned earlier, I'm not big on projects. The closest I can get, as I say, you've got the Mazak videos there for those guys who love project videos. But the closest I can get is making parts. So that's the jobs that make money for me. YouTube videos don't make anything for me. I'm losing money because while I'm shooting this video, I'm not doing any work. So I don't get nothing for making YouTube videos. So this is a part that's basically comes straight off the machine. You can see a bit of a burr in the back there, and I'll walk you through this job inside the machine, as exciting as that could be, and just go through that. I'll just grab a finished part, not really that much different, but this is a part that's already gone through and already been finished. I've already finished, there's I think about 120 sitting there at the moment. I've got 300 in total. The balance of is, I think I've got about probably just over 50 to finish, so it was an opportune time to shoot a video before I finished the job. And the others are already in the box sitting there waiting to go out to the customer. So I get this job a few times through the year, originally processing these on the manual lathe because it's the only way I could do any turning work. Thank you to the CNC lathe finally here. The Mazak was a dream, but it just didn't happen. Things up being a bit of a nightmare, but it was an interesting job, but that's a story for another day. Thankfully I've got the CNC Doosan or DNN Solution CNC lathe now to get jobs like this done. So that's what I wanted to just walk you through that part, as interesting as that could be. As I say, CNC is not for everyone, but just bring you inside the machine, just take you through that setup, and just sort of my semi-automated setup where I have my reasons why I run the job the way I do, just the nature of nylon. I'll talk a little bit about that, take you inside the machine now for a look. So we'll just get the light back on, because while we've been shooting we've lost the light. The light just turns off on a power saving mode. So we've got all the tools are set up in the machine, obviously been running the job, and we've got a heap of swath sitting in the bottom. A chip conveyor would be handy, but I've already covered that in the previous video, why I don't have a chip conveyor. I just have a chip tray down the bottom there. Not ideal, but I don't produce a lot of parts, so it works for me, and it's just a matter of, it's not a big drama to take all the swath out and just put it in the recycling bin anyway. It's normally what I do with it, and recycle any metal, things like that, as you normally do. So as I say, chip conveyor would be a bonus, but if you have the room for it, which I don't. So it works for me, as I say. So if you're interested, to ask me a question, why you got all that swath stuck in the bottom, I should say, I just thought I'd just show you that to cover the wire that's sitting in there, in case you spotted that in the back of in the video itself, I should say. I eventually get my words right. Every time I shoot a video, I don't seem to know what I'm talking about. I probably don't anyway. So bring you inside the machine now. Got the part finished. So what I'll do is I'll just set the part up, and we'll come back and do a dry run through so you can actually see what's going on with the actual coolant turned off, and then I'll just run a wet run through, and then hopefully that'll sort of give you a bit of an idea of how much of a pain in the ass running nylon. Good for tooling, very light on tooling, but it can be a bit of a nuisance as far as chip control and things like that. Nylon's not that, or plastics in general aren't great for chip control, especially nylon. So I'll just get you set up and I'll bring you back. As I'm shooting this video, I'm shooting it in chapters, but for you it all just plays out. So it sounds like if it sounds a bit odd when I'm saying I'm pausing you when you're just watching it continuous. So it won't be an edited video, this is a shoot and post video. So I've got the part machined up to the point where it's ready to part off now. So I've come in, done the bore, done the chamfer on the front, and done the machining on there, as you can probably see in that sample. So I'll just do a dry run through now, because it's the only way you can see it, and then we'll just do a wet run through and just show you the end of it. I won't try and film too much of it when it's actually running with coolant. The reason I run with coolant is mostly for the drill. I have all coolant through tools, so the coolant's already there, so I might as well just use it anyway. I don't really need to use it on most of the turning tool. It's just more so the drill for drilling that hole, where it runs at a reasonable feed rate, and the drill will get fairly hot and start to actually pretty much melt the nylon. So you really only need for that. So I'll just work my way through it and just try and talk a little bit about it as we're working our way through it. So I'll just get it set up and we'll do a dry run. So just coming down from the start of the job, running with the door open at the moment. I'll close the door when I get up to the parting off, because they about probably one in 90 parts, I suppose you could say, gets launched into the next neighbourhood. So I'm definitely not going to have the door open for that, otherwise probably finish up flying and hitting me in the head or something. Spindle running at about 600 RPM, I think. Feed rate of the drill is about 0.7 of a millimetre. So I run the external coolant lines, you can probably see. So that's just so the coolant's flushing down the outside of the drill, not pointing over the top, just hitting the front of the part. So just come in, do a chamfer, and then do an OD tune. So just picking up a bit of fur from the spring cut. And then I'll get out and close the door, and then we'll just part off, and then I'll come back and do another wet run. So I've removed all the swath, which looks like it's not a problem, but I'll come back in the next one and just show you what it looks like after, when I normally do a full run through. So So parts catcher comes up, parts off, and hopefully it doesn't launch it into the next neighbourhood. Yep, worked okay. Normally when you point a camera at something goes wrong. So it drops into the box down the front, and I'll just come back and pick it up. Now, what would be good if it was fully automated, there'd be 15 parts sitting in there, and I just come back and pick them up and put another bar in. The reason for that is, which I'll take you inside and show you now. So I'll get that pre-set up again before we do. So I pull this part out of the jaw 3 inches, and then we'll just get that set up, and I'll come back and talk a bit about why I don't run full automated. So I do have a bar puller, so there's 2 options on, well, there's sort of 3 options for a CNC. You can have a robot if you can justify the part, bar feeder, so bar feeding from the end of the machine, so I'm just hand feeding these parts in from the end of the machine, or you have a bar puller which is set up over there. I did have it written into the program, but I took it out of the program because, as I say, I'll get into further into the video. We'll come back after we run it with coolant. I'll explain a little bit more why, or hopefully it works out for the sake of the video, and you'll understand the difficulties of running it full automated, specifically on plastic or nylon more than anything else. Some plastics are better than machine than others. Nylon's a bit of a pain because it does get very stringy and has, as I say, has that nature of not parting off well and hitting the chuck as the parts are dropping off into the box and then getting launched, as I say, into the next neighbourhood. So I'll just film it for the sake of filming it. You can fast forward it, that's if you're still watching. So we'll just get it going. So we'll just run full coolant this time on all tools. As I say, more so for the drill than anything else, parting off or facing and things like that. Well, facing as far as grooving, I should say, it's for grooving. Eventually I get my bloody words right. Every time I point a camera at something, I don't seem to know what I'm talking about. To put the chamfer on the front is the word I'm trying to think of. So the coolant for the drill more than anything else. As I say, you can see the coolant spraying down the shaft of the drill, so it's shooting it all the way down the shaft, so it's the coolant's following the hole. That's if I can film it. So the coolant's spraying down the whole shaft of the drill, not just hitting the part and then just, as you'll see in most, and you're watching CNCs operating, they just hit the front of the part and then that's pretty much it. The coolant's not doing anything else. So it's going all the way down the bore, covering the drill well, so it's not cooking the part. The drill's running at 0.7, I think I mentioned that already, and 600 on the spindle. So I'll just come in and do the part off now. Definitely the door closed for that one. I'm waiting for it to launch. It added something to the video. It definitely throws it when it hits those chuck jaws. About 99.9% of them drop into the box, but when it starts walking around like that, as it just did, you can hopefully see it. I'm waiting for it to just drop down onto the chuck and launch. So the part's down in the box there, ready for him. Just bringing you back inside and just talk a little bit about the automation. So unfortunately it didn't work out well in this video. Normally we have a whole heap of swarf wrapped around the front, which is the nature of nylon anyway. It doesn't chip break well. You can run your feeds and speed to chip break a little bit, but you're normally always, especially when you're this close to the chuck. I did set it up for bar pull, so I have got it set fairly close to the actual chuck jaws. The swarf will get wrapped around here and also get wrapped around the drill. So even if I wanted to run it automated with the bar puller, I still have to come back, clear the chips occasionally off the drill, otherwise it just keeps backing up on here and you won't get any coolant flooded onto here. So I have to basically babysit it, so you have to keep, so it's just easier just to take that bar puller out of the program and just make it a quicker cycle and just manually set up. It's about 2 minutes per cycle. That's from door open to door close. So each part, so 30 minutes for 15 parts. So it's not too bad, 2 minutes per part. As I say, from door open to door close. So it's not too bad. It would be good to be able to walk away from half an hour and go do something else, but nylon's not exactly the nicest thing. So with the bar puller, just getting you back inside for those not familiar, so you've got 3 jaws on there that grip the part, so that'll grip from 80 mil I think it is, down to whatever, basically down to a millimetre if you want to turn down to that size, so that'll pull the part. So what I mean by that is, CNC guys will know, I'm not telling you anything new. Pretty much the same configuration as what you see on the chuck jaws, 3 jaws. Come down and grab the part at 3 points in a triangular fashion, you could say. The best contact of all. The jaws will open, hydraulically, coolant activated, I wish. Coolant activated bar puller will grab the part, jaws will open, but you get back to what I'm talking about. Pull the part out, jaws will close, coolant will turn off, and then the gripper will move away then. So that's where automated would be good. And as I say, you could just load it up a 1 metre part and then just let it run and go away for half an hour, and then you've got a box full of parts. But unfortunately, as I say, you've got to sort of babysit it and make sure it's all running right. So it's just easier just to stay here and just keep an eye on it. It is a bit of a nuisance standing in front of the machine, but it's no worse than standing in front of a manual lathe running it. And you've got the advantage of it just keeps running and running. You don't have to be mucking around. I am pretty quick at doing it on the manual lathe, but obviously nowhere near as fast as doing on the CNC. And if I could set it up with that bar puller, it would be a lot easier. That'd free me up for at least 28 minutes, I suppose, to be able to walk away from the machine, as I say. But you're going to have problems with swath control, or chip control I should say, which is the nature of nylon. So you get these huge long strips. Normally when I come back, this is hanging off the drill like this, or even wrapped around it. So it's odd because sometimes it's clear, like it is now. I haven't done anything, I've just opened the door and it's all clean. But probably more than half of the time you have swath wrapped around, all around the drill. As I say, it'll just keep getting worse and worse. You could chip break it, but it just adds to the cycle when you chip breaking anyway. So you just plunge the drill in and just live with it, and then just clear the chips out. As I say, it's a bit of a pain standing here watching the machine, but anyway, it just works better for that way. So for those guys who are asking the question, why don't you just automate? You've got a gripper there, why not use it? That's the reason. And I am a bit concerned about when the gripper grabs it with that swath wrapped around the actual part, where it mightn't grip it properly. It might only pull it out, you know, 90% of the way or less than that, and then releases where it hasn't really grabbed hold of it. And it might slip, or it hasn't grabbed hold of it properly, and it might slip it first and then release the part for whatever reason. So I don't trust it that way. It does get a fair bit of swath on here occasionally, and you do have to still clear the swath from on the actual chuck itself. As far as launching the parts go, I did mention I have about 5 that have got launched so far. You can see different degrees of scarring. That's probably one of the worst ones. I have another one that's just got a little nick in the front though, but these I can use these pieces anyway as washers. So I also need to make the same equivalent in washers, so for the customer as well. So they need 300 of the actual parts and 300 of these washers that are 3mm thick. So the material doesn't go to waste. So I still need to run those washers, so that'll all get turned into washers anyway. So I'll just knock that burr off there. The OD on the washers is not critical, just knocking off 3mm sections off there down to here. And this is the only part that will get thrown in the bin. But you need something to hold on to anyway with the chuck anyway. Normally I run those washers out of bar stock, but I've got a few of these left over, so I might as well just use that up. The bore size is the same, just knock those off. So I'll just write another program and just run those off, grip those in the jaw, and then just knock them off. And so I've got pretty much minimal waste. It's just a pain in the ass how they're launching and they're breaking things. So as I mentioned earlier, we have coolant through tools. Parting off op is the last operation, as you can see. So it's thrown the part down and broken the coolant line off here. Not a big deal, it's just a plastic fitting, as you can see there, just like a Festo style fitting. And so as I say, all my tools are coolant through, so just getting easier in there. Remove the part and then just screw another part in there, and then just reconnect the hose again, or fitting I should say, and then just put the hose back on again. So probably over explaining things, but just trying to include things in there that could come up in the comments. As I say, I'm probably over explaining things, but it's just to cover those questions that could come up. Why is it not automated? You've got a CNC, why don't you automate the whole thing? That's just covering some of those things that might come up with guys that might ask questions. So you watch it in the video, it's in the video why I do that. So it's just an easy way to do it. So hopefully you got something out of the video. Didn't really explain anything to you. You know, maybe something you learned something, maybe something you didn't, but it's just showing you jobs that I do. It's not a project, but that's as close as I can get to it. just trying to include things and just add videos to my channel, give you guys something to watch. Still enjoying doing videos, and hopefully you guys enjoy watching. I look forward to seeing you on the next one, and hopefully we'll get some projects organised sometime in the future. Not sure, no promises, and I've still got that Mazak on the go, so it's been pushed out to the back burner now. I didn't get that finished. I finished up buying this machine because I just didn't get time, but I talked a bit about that in other videos about buying that Mazak at the time, why I did that. So if you're interested, go back and watch those other videos. You'll have a card above which will take you to the video for the poor man's positioner. So that should be sitting up above the top of the screen at the moment. So go back and watch that. And if you're interested, the Mazak mission videos, welding positioners and the poor man welding positioners. So go back and watch those and let me know your thoughts about those things you're watching. We'll try to include a few things in my videos. Thanks very much for watching, much appreciated. I'll talk to you guys soon. Okay, bye for now.